In this video, we are going to find derivatives of exponential and logarithmic functions using first principle. In earlier videos, we stated some rules that would help us calculate derivatives faster, but these rules are still incapable of finding derivative of these functions. So we'll have to resort to first principle to find the derivatives of these functions. So we know first principle states that the derivative of a function y with respect to x is given by this limit. And we also know that this limit would always spit out the indeterminate form 0 by 0. So here also it will spit out 0 by 0 form. So to remove this 0 by 0 form, we'll have to apply special formulas for limit of exponential function. For exponential, we apply this formula, and for logarithmic, we'll be applying this formula. One thing to remember here is that this ln means log with natural base. Natural base means e. I hope you are familiar with this property of log in this representation. So now I want to enter into the derivation of exponential function first. First, we'll find derivative of this function. Now, we know how we start to find derivative using the first principle. First, we let this function to be equal to y, and then we state what delta x and delta y are. So let me write it down. Let delta x be a small change in x, and delta y be the corresponding change. Delta y be the corresponding change in y. Now we have to find delta y. For that, we replace y with y plus delta y and x with x plus delta x. Now we move y to this side, so it becomes minus y. That gives us del y is equal to e to the power x plus del x minus e to the power x, because y is nothing but e to the power x. So here, what we do is we separate this using the laws of indices. Which x a times x b is equal to x a plus b. Similarly, x a plus b can be separated like this. So it will be e to the power x, e to the power delta x minus e power x. Now we take common so that it becomes delta x minus 1. So these are delta y. Now you can see some pattern here. We have already gotten the form we wanted. Right? We wanted this form. So now from first principle, dy by dx is equal to the limit. Now we have to write del y. Del y is this term. These are del y divided by del x. If you look carefully, this term here is equivalent to this term. And here x is approaching 0, here del x is approaching 0. So this limit will go to 1. So the derivative will be e to the power x times 1, which is e to the power x. So this is the only function whose derivative is equal to its original function, and that is dy by dx is equal to y. Equivalently, we can write d e to the power x by dx is nothing but ex. Now let's derive derivative of our log function. Yeah. fx equals ln x. Again, we start writing y equals ln x and then stating what our delta x and delta y are. Small change in x and delta y with the corresponding change. It means change in y. Again, replace y with y plus delta y and x with x plus delta x. Again, we take y to the other side. This will give us delta y, which is x plus delta x minus ln x. Now, here we'll have to use the properties of logs. That is, we know if log a divided by b is equal to log a minus log b. So here, this is log a minus log b. So it can be written as log a by b. That is x plus delta x divided by x. Now, this is nothing but x by x plus delta x by x. And this is 1. So it is equal to 1 plus delta x divided by x. So we can write this is ln 1 plus delta x by x. Now, if you remember the property of limit for log, it was limit x approaches 0, ln 1 plus x divided by x is equal to 1. See, 1 plus x, 1 plus delta x by x. We have got this form. So now, we apply first principle. From first principle, dy by dx is equal to limit delta x approaches 0, delta y divided by del x. This is, these are delta y. So, we write 1 plus del x divided by x divided by del x. And the formula, we had x here and x here. So we'll have to equal these things. If here it is x, then we need x here as well. So here we have del x divided by x. So we need to get del x divided by x. To balance this x out, we'll need to multiply by x here. Right. Now if we look closely, this is similar to our formula for limit. Right. Instead of x, here we have del x by x, del x by x. And as del x approaches 0, del x by x also approaches 0. Therefore, these two are equivalent. So this limit will go to 1. And we are left with 1 divided by x. The derivative of log function is 1 by x. So we have calculated derivative for ex, e to the power x. It turned out to be e to the power x. For log x, it turned out to be 1 divided by x. Now we can calculate derivative of any type of functions. If it is, whether it is algebraic, whether it is trigonometric, or whether it is exponential or logarithmic. We can calculate derivative of any type of function that will involve these type of functions by using the rules in derivative. For example, Let's say we have a function like this. Sin x times log x plus e to the power x square. Let's say we want to find derivative of this function. Now, we will apply the rules we have learned and separate these functions like this. So here is sum. So we first separate it like this. Now we have two functions in multiplication. So we'll apply product rule here and also another product rule here, because we know what is the derivative of e to the power x. We know the derivative of ln x. We know the derivative of sin x. We know the derivative of x squared. So we'll apply the product rule. Therefore, now we can easily find derivatives of any type of functions by just applying the rules properly. In next video, we will be finding derivatives for some mixed functions, and we'll also learn how to calculate derivative easily. Thank you.